Cool. You can all join the quiz. I'll post the details in the chat as well. And then we can, yeah, get going. The password to join is pretty long today, but we'll just test. I see someone's already managed to join. That's cool. So menti.com and 10 or 1033861. Yeah, that is one longer than usual. Hey, I know it's sometimes we have some really short ones, and then other times they have long ones. Don't know if they ever reuse them. If they don't, then by the end we're going to be using like 10-digit codes. So I'll wait for some more people to join for like a couple of minutes, and then we'll just get started. Main thing is to use the quizzes as a learning experience. I think I am recording now. Yes, I am. Cool, so we're just moving. Ah, cool, we've got some more people joining the call as well, so that's cool. See, okay, so yeah, awesome. I'll give you guys like another 30 seconds or so to join. I posted the URL and the code in the chat. And if not, then we'll just get started. I think it's just a good way to learn the way that the MTA asks questions, these quizzes. Another person, cool. Okay, let's get started. Remember that you can join the quiz partway through and figure out whether or not by answering the last few questions you can still amass an okay score. Okay, so on to the first question. It's just a fill in the blank question you're going to have to type. An is an instance of a class. So you have to fill in the blank. Faster answers do not give a higher score, so you can take your time on this one. Make sure that you spell things correctly. And there's plenty of time, so you might even have time to check out the textbook or the PDF rather. See if you can complete it. Might have actually given too much time on this question. Ah, Clark, you answered in the chat. You mustn't give away the answer. Okay, 2 people have answered. Cool. Doop. Let's see what everyone answered. So object, method. Yeah, the correct answer is object. Yeah. The correct answer is indeed object. So nicely done to those of you who answered that. No, it doesn't give a count. But yeah, the correct answer is object, because apparently 3 people answered, but there's only 2 answers here. Weird. An object is an instance of a class. Okay, let's go on. Which of the following class elements would define the behavior of a class? So if I wanted to define a behavior in my class, which of these elements would I use? You haven't heard this wording before, but I did want to introduce it to you before. What's another way to think about behavior? It's something you do, right? Ah, okay, I gave it away there, I see. As soon as I said it's something you do, 3 people answered. Cool. But yeah, so this is another way that they word that idea. Okay, interesting. So I'm glad none of you said static or public, and that's cool because those aren't class members. They're a way to describe class members. So I'm glad none of you guys answered those. 1 person said property, 3 people said method. And so yeah, the majority is correct here. Property defines something you have, right? Attributes. A method defines something you can do, which behavior is another way to say something you can do. So nicely done on that one, guys. Which class member or members would be used to define the attributes of a class? Oh, okay, well, this will test whether you guys were listening to what I said on the previous slide. Cool. Everyone got that right, and I'm glad about that. That means you guys were listening on the last slide, so that's cool. So yeah, methods we've just seen define behavior. The class is the class. It's not a class member. And variables, that was a bit of a trick. I'm glad no one fell for it. Properties are kind of a special kind of variable, right? So properties is the more correct answer, and so that's the one you should use. Okay, another question. I think this is the second last one. You can use a to group related classes in order to reduce name conflicts. So how would I group related classes? What's the word we use for that? Okay. Bit of a difficult one because again, you haven't heard this wording before, but I imagine that when you guys see the answer, you'll understand this definition of it. I'm just exposing you to this wording. So how would we group related classes in order to reduce name conflicts? So in order to be able to uniquely identify a class, what do I put it in? How do I group them? Okay, no one's got this one yet. That's interesting. In a way, that's a good thing because that means it is almost learning. How would we group related classes? Ooh, looks like no one will get this one. Interesting. This one was quite difficult. Ah, okay, someone's answered. I hope you got it right. That would be cool. In a way, part of the answer is actually in the question. But I've told you that 5 seconds before time up, so it won't help. Okay, let's see. Oh, okay, some people did answer quickly. Ooh, okay. Interesting. So no one quite got it correct. Someone got maybe pretty close. So the answer is namespace, guys. So remember, you might not have realized that's about this wording. You might not have realized about this wording, but you can see that we're in namespace Rex tester here on like this little on Rex tester, but you can have any namespaces you like. And the namespace allows me to reduce the number of name conflicts because let's say there was another class called program inside the system namespace. I can uniquely identify my program as rextester.program, and the program inside system would be system.program. So namespaces allow us to reduce name conflicts. Okay, cool. But yeah, I mean, good try to the person who answered name class. Okay, last question. Which member of a class should initialize the values of the properties of a new object? So how do I initially set the values in a new object? What do we call the thing that does that? And this we did cover in last week, so hopefully some people were listening. So how do I initialize? It's quite a mouthful to say that question, but how do we initialize the attributes or the properties or the fields of a new object? Another way to say it would be, how do I create a new object? And in the last couple of seconds, I'll say, the other way to say it would be, how do I construct a new object? So yeah, 100% of you got it correct, so that's very cool. But that does mean that it'll come down to who got it fastest. Huh? So yeah, that's nicely done by all of you there. Cool, Earthman, you won, good job. But that was a very close one. You guys all were very close. You guys all got the same number of questions correct. It's just that Earthman answered the fastest, got them correct the fastest. Cool. Nicely done, guys. You guys all did well there, so I'm glad about that. Chapter 2 is a pretty tough one. Lots of new words, and we will be learning a lot of new words today because we are covering the most important concepts in object-oriented programming today. So those important concepts, I'll introduce them to you. They're on the title slide there. In fact, one of them is missing here. There is 4 important concepts in OOP. So let's just get started. So yeah, I do want to spend some time just revising what we learned last week. Hopefully the quiz refreshed your memory about a lot of it, but I want to show you what it looks like in code. And yeah, we'll also spend some time maybe setting up a quick example, or at least setting up for that example. So last week we saw a class like this, all right? This was the first class that many of you guys have seen, I imagine, or maybe even all of you, was the person class, all right? So we defined a person class that had 3 fields. So each person will have 3 attributes, a weight, a height, and a hair color. Yeah, you guys remember that? And they were int, double, and string. And we saw that you can use really any variable types you want, right? And you can call them whatever you want. So we defined these attributes for our person. We also defined a constructor, which allows us to create new objects of type person. And we also defined some behavior for our class. We defined the ability for each object to describe itself. So I've got a describe method here. Looks a little bit, it's the same, it's pretty much the same as what we had last week. It looks slightly different. I think things are in different order. I just redid this now. And then we created 3 objects of type person. Here I just created myself. So I created an object called Josh, set a weight, a height, and a hair color, and used josh.describe so that I called the method for this object to describe itself. Okay, so that was the class that we saw last week. And we also learned about the word static, right? We learned about the word static, which was a method. You can call a method static to make it belong to the class instead of belonging to an object. Okay, so then I could call the method without having an object if that method was static. So that's the other thing we learned about last week. I do want to introduce you guys to one new word because it might come up and it's pretty quick to learn and I think pretty easy. So if you're using a variable inside an object, or inside a class, obviously when you actually use it, it would be inside an object, an instance of that class. You can also use a keyword called this. So in order to introduce you to this, there's a pretty nice way to learn about it. You see in my constructor, so this takes in an integer called W, a double called H, and a string called hair color, or HC rather. And obviously the W is short for weight, the H is short for height, and the HC is short for hair color. And you can see I pass those into, when I'm creating a new thing of type person, I pass in the weight, the height, and the hair color, right? The reason these are called W, H, and HC is because weight, height, and hair color are already taken names, right? You can see my attributes are already called weight, height, and hair color, right? So when I actually set those attributes, I set weight to W, height to H, and hair color to HC. So I couldn't call them the same name. Well, actually, I could call them the same name. I would just have to use a special little trick. So I could instead call int W int weight. And I could call double H double height instead. And I could call string HC string hair color. I am allowed to do this. Okay. You'll see that initially it looks confusing, right? So I'll just type it out and then you'll see. So here, when I say weight equals weight, it's impossible for C# to know which weight is on the left. Like, is this weight on the left or is this weight on the left? And is this weight on the right or is this weight on the right of the equal sign? And so C# has a special keyword that you can use in this kind of case called this. So you see if I type this, it's highlighted. What this means, if I'm inside a class, is that I'm referring to this instance of the class. So when I create Josh and I pass in the weight, height, and hair color, if I use this, then it's referring to the version of weight that is owned by the object. So you can see that it'll, when I say this dot weight, it refers to this weight over here, the one that I've just highlighted. This dot height will refer to this height, and this dot hair color will refer to this hair color. So I can differentiate even though the names are the same. And you'll see that that still works. Okay. So that's just a special extra keyword that I want to introduce you guys to. So this refers to this instance of the class. So it makes quite a lot of sense. You can even read it almost as English. All right. Again, we're going to be learning a lot of new words today, and indeed most of chapter 2 comes down to learning a bunch of new words. Okay. So let's continue. That was just some revision of classes. And as I mentioned when we started the lecture, today we are going to be learning about 4 important aspects of object-oriented programming. In fact, the most important aspects of object-oriented programming. These aspects are inheritance, polymorphism, abstraction, and encapsulation. Okay, those are their names. That's what we call them. Again, four new words, maybe words that, I mean, you've seen the word inheritance before, and that word, it means a similar thing. You've probably seen the word abstraction before, and again, it means a similar thing to just how we use that word in English. Polymorphism and encapsulation might be new to you, but for all of these words, the standard English definition does actually provide quite a lot of help in understanding the concept. So we're going to go over these in 4 important aspects of OOP, and once you learn all of them, you'll have a very good understanding of object-oriented programming in general that can be applied to any language. So C# is an object-oriented language, but also Java is, and Python, and many, many other languages are object-oriented. So this understanding will help you in all of those. So let's get started with inheritance. So again, the standard English definition of the word inheritance will help us here. I mean, let's actually just search that up. So inheritance, okay, apparently it is a movie, but we're just going to say define inheritance. Okay. So a thing that is inherited, fair enough, the action of inheriting. Okay, those particular definitions are not super useful. Let's instead search up inherit. Cool. So receive as an heir at the death of the previous holder, pretty good one. The second definition is more relevant. Derive a quality, characteristic, or predisposition genetically from one's parents or ancestors. This is a pretty good one for us. Receive or be left with from a predecessor or former owner. That's a great one. Okay, so this is the standard English definition of the word inheritance. So let's see why it's called inheritance inside C#. So we've seen that we can define classes, right? We've seen that we can define classes, and classes can inherit from other classes, almost like children can inherit from parents. Okay. So for example, we have a person class. Okay. We could create other classes that inherit from the person class. For example, I could say doctors. I can create a doctor class, and all doctors will be persons with some extra stuff, right? So a doctor is a person that has some extra attributes or some extra behavior. Okay, so there's extra things they can do. So a person might be able to run, like that might be a behavior that they have, and a doctor might be able to do surgery and to run, for example. Okay. A nurse is the same, right? So a nurse is a thing of type person, but they have some extra attributes as well. So for example, a person might be able to describe themselves using the describe method, but a nurse might also be able to describe themselves, but just in a slightly different way. Okay, so there's this idea of inheritance, and we'll expand upon it a little bit more in today's lecture. Okay. Another example of this, a good example of inheritance in classes, is that I could define a polygon class. Okay, polygons are just many-sided shapes, right? Any many-sided shapes. Poly, in fact, just means many. I think gon means shape or corner or something. So a square is a polygon, right? A square is a type of polygon. So a square could inherit from the polygon class. Likewise, a rectangle could inherit from the polygon class. Okay. And so you can see I can create any class, and then I could create more classes that derive from or inherit from greater classes. So what do we call this? So the class, the main class, so the person class or the polygon class or whatever other class that we're talking about, is referred to as the base class, the base class. So here, polygon is the base class. All the classes that inherit from polygon are called derived classes. So square derives from polygon or inherits from polygon. So square is called the derived class. And rectangle is also called a derived class because it inherits from polygon or derives from polygon. Okay. So let's go ahead and see how this works and just start figuring this out. Cool. So I'm going to, I think, so we've seen this person class and we've played with it a little bit. So I think let's move to the example on the right. This is the example that's more similar to the one that you'll get in the textbook. It starts on page 34, but you'll see it all here, so you don't actually need the PDF open. So yeah, we're going to move to this example on the right where we have polygons, squares, and rectangles. So we're going to create that structure on the right using C# class inheritance. So in order to do this, I'm going to jump over to Rex Tester. I'm actually going to delete our person class here. Because we're going to be creating a different class. So I'm going to create a polygon class, which will be quite simple. All I'll say is public class polygon, and further on from that, I'll say that a polygon is a thing that, again, this is not the formal mathematical definition. This is just going to be the definition that we use in our example here. I'm going to say that a polygon is a thing that has a length and a width. All right. So I'm going to say that a polygon is a thing that has a length and a width. You guys, could you suggest what data types could I use to set the length and the width? Let's get some interaction going. What data types could I use to set the length and the width here? Create the length and the width properties. Any suggestions on that? Which data types would I use to store a length and a width? They're numbers, correct? Seems like we're still sleeping this Saturday morning. So there's quite a few data types that we can use to store numbers, right? We can use ints, doubles, floats, anything you like. Here, I'm going to keep it simple, and I'm going to make my length and width integers, right? Just integers, just to keep it simple. So I'll say public int length. That's going to be the length attribute or property or field. And I'm going to set public int width. Okay, so each polygon has a length and a width. What will I need in order to create a new polygon, guys? What will I need to create a new polygon here? What structure do I need? I'll pick on you if you don't answer. Let's get Yusuf. I'll get you to answer it. What structure do I need to add to this class in order to set the length and the width? Do you know? What do I have to add? What's it called? What's its name? Anyone else? You can help Yusuf out if he needs. It'll be the same as in our person class, guys. It has the same name. How did I set the attributes of a new object of type person? Okay, I suppose. There we go. Okay, so Chris saved us there. So yes, we need a constructor. We need a constructor to set the length and the width. So the special rule about constructors, guys, is that they have the same name as the class they are constructing for. So I'm going to say public polygon. All right, there we go. Now someone else can help us out as well. What two things is the constructor going to have to take in? Or what? So it's going to take in two things. I'll give you that. That's a hint. But what are their types? What are their types? Let's see. So in the class that I've just created here, in order to create a new object, what two types? It's going to have to take in two attributes. What are those attributes types or type? What is the type of those attributes? It has to do with the type that the class uses to define its attributes, no? So remember when we took in hair color, weight, and height, we had to take in a string, an integer, and a double, because those are the three attributes that we were trying to set. In this case, what attributes am I trying to set? What are their types? Anyone? Okay, I'll spoil it. I hope no one's answering because it's easy or no one's guessing. And you guys are welcome to guess when I ask these questions of you, okay? So the type for length is int. The type for width is int. So the two variables that my constructor has to take in will be two variables of type int. For example, int L or int W. Okay? And then I could say length equals L and width equals W. All right. Now, understand that I could also use that little trick, right? I could call these length and width and then differentiate between them by saying this dot length equals length. If you added measurements, i.e. centimeters, would it then be a string? Yeah, precisely. So Chris asked that. If we wanted to add like 10 centimeters, then the cm we would have to store in a string. precisely, yeah. And we could say this dot width equals width. Cool. So that's our constructor. We'll now be able to create something of type polygon. Okay. So let's try that out. I'm going to create a new object of type polygon. And let's say I'm going to set its length and width to, I'll go with 10 and 20, just to keep it simple, okay? So all we have to say is polygon. So if you guys remember, just to draw the analogy here, when we created a new thing of type person, we said person, the name of the person equals new person, and we specified the weight, the height, or whatever attributes we needed to construct. So this is basically how we created a new person, right? Watch how similar it is to creating a new polygon. I'm going to say polygon, poly, I'm going to call my polygon poly, equals new polygon. And I specify the length and the width as integers. If they were doubles, I'd have to give it doubles, right? So notice how similar it is. Also notice how similar it is to creating just a normal variable, right? If I'm creating a normal integer variable like int x equals 6, it's very similar, right? We've basically just created our own type. When we create a class, we're creating our own new type. Okay. So that is that. So we've created a polygon class, okay, over there. On the right here. The next job is to create squares and rectangles. So in order to set this up a little bit more, I'm just going to explain why this makes sense. All right. So a rectangle has a length and a width. A square has a length and a width. So you notice they have this in common, right? They have this in common. They both have lengths and widths. What differentiates a square from a rectangle is that a square has equal length and width, right? So we can now define this concept in code, and I'll explain more as we move through it. Okay. Cool. So what I'm going to do is actually say, you know what? You're not going to be constructing something of type polygon. Polygon is going to define an idea, right? So the constructor for polygon, I'm actually just going to remove, right? So a polygon now is just a thing that has two integers. One is called length and the other is called width. That's all a polygon defines. Okay. How you actually use polygons is I'm going to create two other classes. Public class square and public class rectangle. Okay, so we've got these two other classes. What I want is for square to inherit the length and the width of polygon, and I want for rectangle to inherit the length and width of polygon. How I type that is I say square colon polygon and rectangle colon polygon. So what I am saying here is that square and rectangle inherit from polygon. That's how we say the colon. Okay, so square inherits from polygon, rectangle inherits from polygon. Now I'm just going to use this quickly just to show you what's going on here. Okay? Before we create any complicated constructors and stuff. Okay? So what I'm going to do is I'm going to create something of type square. So square sqr equals new square. Okay, and I'll do something for rectangle as well. So I'll say rectangle rect equals new rectangle. Okay. Now you'll notice this works. Okay, it runs. So something is going on here. You can see square and rectangle are actually empty. Okay? I don't have to define a length and a width for them. What I'm going to do instead, and if you guys want to follow along, you could see some of this in the PDF that was shared on the group. Let me just so that you know, in case you want to make notes or something. It's pretty far into the book. I don't know why they understanding inheritance. It's on page 49, guys. So this kind of thing is on page 49 here. So we've got these two. So a polygon defines the length and the width. Square and rectangle inherit length and width from polygon. Okay, just going to zoom in a little bit so that we can focus on this section. What I'm going to do is just define a constructor inside square and a constructor inside rectangle. And you notice the constructors have the same name as the class that they are in, right? So the square constructor is inside the square class, and the rectangle constructor is inside the rectangle class. Now, here's an important question. So yeah, this is an important question here. This is where things get interesting. This is why it's useful. How many numbers do I need to define a square? How many numbers do I need to define a square? So I just want to define the sides of a square. How many numbers do I need, guys? Can someone tell me? Do we need 2, Yusuf? So are you thinking length and width? Length and width. So interesting thought. But what's special about a square, Yusuf? What's special about a square? What's special about the length and width of a square? All the sides are equal. So you see the length and the width of a square will be equal. So I actually just need one number. So let me show you what this would look like in code. My square constructor is going to take in one number, length. And it is going to set its length. Notice there is no length attribute defined in square. The length attribute is inherited from polygon. Okay, it is inherited from polygon. I'm going to set the length to L, and I'm going to set the width to L. Okay, they are the same. The length and width are the same. So I needed one number. How many numbers do I need to define a rectangle? Okay, pretty easy question now that you've seen the trick for square, because square was the special one. Exactly. So if we now need 2, because now the length and the width are different. So my rectangle constructor is going to take in 2 integers, an int called L and an int called W. And it is going to set the length equal to L and the width equal to W. So the distinction here, remember, both of them inherited length and width from polygon. But these two classes are now defining something strictly different. They are defining something that has different behavior. And so here, when I construct my square equals new square, I'll give it one number, let's say 10. When I construct my rectangle rect equals new rectangle, I'll give it 2 numbers, let's say 10 and 20. Okay. And so you can see that using this idea of inheritance, we're able to define, I'll leave it zoomed in a bit, just because it does get a bit crazily small. We're able to define a pretty complex idea. So you can see when I run this, it does work. So C# understands what's going on here. Even though length and width are not defined in rectangle, you can see there's just a constructor in rectangle. There's just a constructor in square. They both inherit their length and width attributes from polygon. Okay. So that's the idea of inheritance. We're able to inherit attributes, but also methods from a class. Cool. So now let's start seeing where this gets super interesting. So we see now that we can inherit attributes, right? Like length and width. We can also inherit behavior, like methods. So one interesting thing that we can do with a polygon is calculate its area, right? So we can calculate the area of a rectangle and the area of a square. Do you guys remember how to do that? How do I find the area of a square, guys? Or let's keep it simple. Let's say area of a rectangle. How do I calculate the area of a rectangle? Length times breadth. Precisely. We take the length times breadth, or length times width, right? Whichever you want to call it, okay? So length times width in our case here would be the area of a rectangle, which is the same as the area of a square, right? You just take the length times the width, right? Yeah, exactly, the side times side. So if I take the length times the width of either a square or a rectangle, it will be able to give me the answer, right? So for example, if this was working correctly, the square that we created, it has all sides are 10, right? This square, all of its sides are 10. So 10 times 10 is 100. So the area of our square would be 100. The area of our rectangle is also length times width. So in this case, 10 times 20, which will be 200. Okay? But notice that in both cases, it is length times width. So what I am going to do is inside the class called polygon, I am going to define a method called area, okay, or get area. So a method that calculates the area. So what I'm going to do is say public, right? This is going to have a return type. It's going to return some type. I want you guys to tell me that type. We're going to call this method area. Okay. It doesn't have to take in anything because the polygon already has its length and its width. And it's then going to return something. Okay. It's going to return something. Right. You guys are going to help me in chat complete this method here. Okay. What type will the area of our polygons be? This is it's a pretty special rule, but I do want you guys to try and get it yourselves at least. So what type do I know that this will return? The length and width have a certain type. Actually, let's start with the easier question. How am I going to calculate the area of one of the polygons that we have defined here? What is the exact C# code that I'll write? Where I write return here. So I'm writing return. What will I be returning here to get the area of the polygon? Remember, we have our two attributes. How do we use those attributes to calculate the area inside C#? You guys have told me already in a way, right? It's side times side, or length times breadth, or length times width. How do I write that inside this C# code, guys? And feel free to guess. It doesn't matter if you get it wrong. What matters is that you're thinking. How will I define it? How will I define it? I'll tell you this, right? So our length attribute is over here. Okay, public int length, and our width attributes is over here, public int width. How do I use those two attributes in C# to calculate the area? Anyone know? So how do I say length times width inside this C# code? Length times width. Exactly, okay, blessing, got it, so that's cool. We'll say length asterisk, because asterisk is multiplication inside C# times width. So the next question is, what is this type? So I have taken length, the length attribute, and I've multiplied it by the width attribute. I need to tell C# what type this is returning. So this says return length times width. What is the type of length times width, guys? Does anyone know? What type will it be? It's guaranteed to be a specific type here based off of how I've defined things. Length and width are what? What are they? Tell me that. What are the length and width attributes? What type are they? The length and width attributes are what type inside this class? They're integers, exactly. You can see public int length, public int width. So yeah, Chris, they are integers. And so what I'm doing here when I say length times width is I am multiplying an integer by an integer. So what will that give me? What will that give me? Anyone know? Okay, this is a bit of a mathematical rule and you can prove it to yourself. Whenever you multiply an integer by an integer, you get an integer, okay? There are no exceptions. There are no exceptions. And so length times width will be an int. And so this is the area method. We have defined a method that will calculate the area of a polygon. Notice, square and rectangle inherit from polygon. They never define the area method themselves. But what we're going to see now is I'm going to be able to say console.writeLine square, or SQR, because that's the name of my square object, square.area. Just like when we were saying person1.describe, it's very similar. And then I'm going to say console.write rect. So that's the name of the rectangle object, rect.area. Okay. And when I run this, you can see that I get out 100 and 200, which we said would be the correct area of both my square and my rectangle. So notice the square and rectangle classes never define the area method. They inherit the area method from polygon. Okay, so this is inheritance. This is why it's such a powerful idea. Okay, I could define the area method once, and every single method that inherits from polygon will have that same area method. Okay, so that's the first important concept of object-oriented programming, inheritance. Classes can inherit attributes and methods from other classes. Okay. What do we call this? Here, polygon is the base class. It is called the base class. I will share this code with you guys if you ever want to go through it again for studying or whatever. So I'm going to comment it a bit. This is our base class. Okay, base class. The square and rectangle methods, so I'll say, or classes, sorry, square and rectangle classes are derived classes, derived classes. Okay. So those are the names we use for them. If a class inherits from another class, it is called the derived class. The class that it inherits from is called the base class. Okay, cool. So that's inheritance, guys. Quite an interesting idea. And you can imagine with other classes, we could do this as well. For example, we could create a class called car, right? And then we could have another class called BMW and another class called Audi, and they could both inherit from the car class, for example. But you can think of many different examples where it might be useful, right? We could define a class called flora or plants, and we can have a class called tree that inherits from the flora class, and another class called flower that inherits from the flora class, for example. Okay, there's a bunch of places we can use inheritance. This is just one example of where it might be used. All right. Cool. So that's the start of inheritance. There is another aspect to it, which, okay, it's not time for a break yet. We still have 5 more minutes. So let's start with this second concept of inheritance. There's a way to control how inheritance occurs. So you can see that this is quite a complex idea, allowing all classes to inherit from all other classes. It's a pretty complicated idea, right? A lot could go wrong and a lot of different things could happen. So where C# gives us 2 words that allow us to control how we inherit from classes. Those 2 words are abstract and sealed. Abstract and sealed. You know what? Tell you what, guys, before we continue discussing abstract and sealed, we will just do a 10-minute break now. So we'll break until 10 exactly. Okay. We'll break until 10 exactly, and then we'll come back for a little bit of a longer session. I am just going to pause the recording so that the people watching on YouTube do not have to watch the break. Feel free to ask any questions during the break if you like. Okay. We're going to get started again. So we just finished a break. For those of you watching on YouTube, you didn't miss any questions. This is a problem because I do remember when we were students at Wits, undergrad students, we were complaining that lecturers should record their lectures, and none of the Wits lecturers like to, because too many people watch the lectures recordings instead of attending. And yeah, nothing replaces attending, I don't think. Okay, so we were discussing inheritance, and we were saying, you know, this is a very powerful idea, but perhaps even a bit too powerful, if you like. It's very difficult to imagine what could occur in certain situations, right? If something was inheriting from something, was inheriting from another thing, it would get really complicated. So C# provides two words that allow us to control how inheritance occurs. Okay? So the two words are abstract and sealed. So just by considering this one example, you can get a good understanding of what abstract and sealed do. Okay. So let's first just explain this little example that we've got here. Okay. This is very similar to what we're doing in Rex Tester at the moment, except I've removed the square from the equation, okay, just to keep things simple. So rather than, you can see that we can inherit multiple times, right? So square and rectangle inherit from polygon, and that's totally fine. I'm going to remove square now. Okay, so I'm just going to remove square just to keep the code simple and focused on what we're learning. Okay, so I'm going to remove square. And so we just have rectangle now. So rectangle is derived class, is the derived class. Okay. So when you look at this, you can see, so polygon is our base class, rectangle inherits from polygon. Okay, it inherits both its length, its width, and its area method. Notice now that I can create objects of type polygon, as I did at the beginning. So I can say polygon poly equals new polygon, right? I did that right at the beginning. Notice polygon doesn't have a constructor, so I don't provide the length and width. It just exists, okay? Polygon, it just exists. Polygon poly equals new polygon. It doesn't have a length and a width set. It has the length and the width attributes. I could access them, but they're not set. Okay. Rectangle rect does have its constructor. So it actually requires, when I create an object of type rectangle, I actually had to specify the length and the width there. Right? Now, in this case, it seems a bit weird, right? So polygon was defined specifically just to allow us to inherit from it, right? We only wanted to be able to inherit from polygon. The fact that I can create an object of type polygon is pretty silly. Why is it silly? Well, the area method, just as a simple example, you can imagine for a number of reasons why you wouldn't want to be able to create an object of a certain class, like you just want to inherit from it. But in this scenario, you can imagine that polygon doesn't define its own constructor. I can't actually construct an object of type polygon here because it doesn't have a constructor. You can see there is no method called polygon. There is no constructor here. So I can't set well, I could, but I can't immediately, I can't guarantee that the length and width of a polygon object is set, right? There, you can create, like this polygon poly doesn't have a set length and width. And so I could hypothetically call poly.area, let me just show you guys. I'll actually do it. So you can see that the constructor doesn't set the length and the width for the polygon object called poly. So I'm just going to say console.write poly.area. Okay. Now it is okay because C# by default, when it creates an integer, if you don't set the integer, it'll just be set to 0. So essentially this just said 0 times 0. But why would I even want to give you the headache of having to remember not to call poly.area, but to instead call rect.area? Because rect actually has a length and a width. Poly is just a random thing, right? It's just C# just created it. You shouldn't really be able to create an object of type polygon, basically, is what we're saying. You can also imagine a situation where you don't want to be able to inherit from something. And so abstract and sealed provide ways to control this. So this is the example that we're considering here, and it's the one that I've displayed in this little diagram. So let me just explain how this diagram relates to what we just saw in code. We've got the polygon class, right? We've got a rectangle class that inherits from polygon. Okay, so that's what this downwards arrow is showing. The rectangle class is inheriting from polygon. We can then also create a polygon object, which we did by saying polygon poly equals new polygon. And we can create a rectangle object by saying rectangle rect equals new rectangle, and then giving it the length and the width. So this is the relationship that we now have in RexTester, okay, in our C# code. What the word abstract and sealed mean can be shown very easily on this diagram. So let's say, hypothetically, we make polygon abstract, okay? Like the word abstract means in English, what this is telling C# is that polygon is defining an abstract idea. It's just defining an idea or a concept. It's not defining something that can be actually embodied. So what the word abstract tells C#, if I make polygon, the polygon class abstract, that would mean that I am not allowed to directly create an object of type polygon. Okay? In order to maybe help you guys out a little bit, like I was saying, the English definitions of the words do display this quite effectively. Okay? But let's just see it in code. Okay, so how would I do this? It's fairly simple. I would just type abstract here, abstract public class polygon. And now when I run this, you can see that because of this line here, it says, okay, there's an error on line 16. Okay, on line 16, you can see it's telling me. So if I go to line 16 is this polygon poly equals new polygon. And what it says this error is it says you cannot create an instance, so an object, you cannot create an object of the abstract class polygon, okay? So I am not allowed to create an object of type polygon. Okay? So if I comment out this line where we create an object of type polygon called poly, and I run it again, you can see that C#'s now totally okay with this. So what the abstract keyword means when applied to a class, okay, when I call a class abstract, what that's saying is that you can only inherit from that class. Okay? You can only inherit from it. You cannot create an object of type polygon. You can only inherit from it. Okay? So that's what abstract means. So it just means that that class is an idea. It's a concept, it's an abstraction. It isn't something that can be turned into a physical object. Okay, that's what the abstract keyword is saying. Sealed is kind of like the opposite of that. So consider, let's say I made polygon sealed. So instead of abstract, I write sealed. If it is sealed, that means it can only you can only create objects from it. You are not allowed to inherit from it. So sealed means that you are not allowed to inherit from the class. Okay, so you can see that so abstract makes that relationship there. You would no longer be able to create an object of type polygon. Abstract makes that impossible. Sealed makes the other relationship impossible. You would not be able to inherit from polygon, which makes all of that impossible. You wouldn't be able to create this rectangle class inheriting from polygon. Okay. So let me just actually show you what that would look like in code. So if I go here, and instead of making polygon abstract, I make it sealed. Okay. And then I try to run this, we'll now get a lot of errors. So it'll say, there's an error on line 34. So if I go to line 34, you can see the error over here. What this is saying is rectangle cannot derive from sealed type polygon. So because the polygon class is now sealed, rectangle is no longer allowed to inherit from it. Now, obviously, I could then try to make this work by saying, okay, rectangle no longer inherits, but that's going to create another problem because now length and width are not defined in rectangle. Okay, so we're not going to go down that rabbit hole of making the polygon sealed, because polygon is supposed to be abstract, right? We're defining this idea of a polygon that we can inherit from. What would make sense, though, is if we made rectangle sealed. So now what the relationship we've defined here works. Okay? So what this is saying, abstract class polygon. This is an abstract idea of a polygon. You are not allowed to create an object of type polygon. You can create an object of type rectangle, and which inherits from polygon, but you cannot create a polygon directly. It's an abstract idea. We also made rectangle sealed, which means nothing can inherit from rectangle. Rectangle is like the lowest level. It's supposed to be turned into an object. It's supposed to be used as an object directly. It's not supposed to be inherited from. Okay? So abstract and sealed are just two words that C# provide for us that we can use to control which objects can be inherited from and which objects can only be inherited from. So abstract means that you can only inherit. Sealed means that you cannot inherit. Okay. So yeah, that's abstract and sealed. Just two keywords that C# allow us to use to control how inheritance works in our code, okay, between all our classes. All right, so that is inheritance done. That is one of the 4 important concepts of OOP. The remaining ones, I would say encapsulation maybe gets a bit heavy, but the other 2 are okay, I think. So I'll just go back to that slide where we show the 4 important concepts of OOP. So we've got inheritance, polymorphism, abstraction, encapsulation. Okay? So we're done with inheritance. We're now going to discuss encapsulation, right? Encapsulation. Now, again, the English definition of the word does actually provide a useful way to understand this idea. Okay, it's well named, and you'll notice all 4 of the important concepts in OOP are fairly well made, fairly well named. So if I say encapsulation define, you can see this is the action of enclosing something, okay? Or to put in a capsule. Okay, so enclosing something is to encapsulate it. And it means a similar thing here. Encapsulation is about security. It's enclosing things to protect them. Okay? Encapsulation is about security. And there's a number of important keywords that we will learn in this section. And you can see it on page 48. Page 48. These keywords are public, private, protected. Public, private, protected. These are the keywords that we are going to be learning now. Cool. So I'm going to simplify this example to move it away from discussing inheritance towards discussing encapsulation. Okay, towards discussing encapsulation. I'm going to remove, actually, we can even leave the abstract and sealed keywords there. In fact, this example will work quite effectively, I think. So I'm gonna make it so that polygon is no longer abstract, and there we go. So we've seen this word public, right? We've seen this word public, and it's come up quite frequently, right? So you can see I've got public class polygon, public int length, public int area. This word public appears in a lot of different places. Okay. And that's okay. What public means is that it's accessible anywhere. If something is set to public, that means that it is accessible anywhere in your code. So we're going to stop thinking about rectangles for now. So I'm going to not create this thing of type rectangle. And I'm just going to work with the polygon. I'm going to work with polygon. So what I want to show you guys, because length and width are public, I can access them directly. So look, I'll show you now. So I'm going to say console.write. So I've created a polygon object here. It has a length and width. They're not set, which means C# will also automatically set them to 0. So what I'm going to do is say console.writeLine poly.length. Okay. And I'll also say console.write poly.width. And I'm going to run that to print them out. So they're both 0 initially, as we expected, because there's no constructor. Because they are public, I am able to access them and modify them anywhere in the code. So here in main, I can say poly.length equals 10. Okay. And when I run this again, you'll see there's no trouble, and it just changes the length of polygon to 10. And I could say poly.width equals 20. Okay. And you can see now that poly.width has changed to 20. Okay. Because they are public. Because they are public. So hopefully that makes sense. And the word public makes sense there, right? It's a good word to use to describe that relationship. That it's accessible everywhere. That's what it means, even in English, for something to be public, right? So I'm just commenting out the rectangle class so it doesn't give us any errors while we're working with the polygon class. Okay. The next thing is to say, okay, so we have public. That means that it's accessible anywhere. It's perfectly reasonable to assume, though, that maybe we don't want to be able to allow you to just modify the length and width of the rectangle however you want. So I'm going to give you a simple example in this case of how this might break things, but you can imagine it in other cases as well. For example, if you're in a bank, right, you might want to be able to, for example, allow someone to view their bank balance, but they mustn't just be able to go like account.balance equals millions, right? That's not allowed. Right? You can't just modify your bank balance in any class. You might be able to view it. So you could say like account.balance just to print it out or something, but you wouldn't want them to be able to modify it. Okay? And it's similar here, right? So look, we currently, because length and width are public, you can modify them however you want. You can say poly.length equals 10 and poly.width equals 20. But that's not the only restriction, right? You can just, there is no restriction because they are public. I could say poly.length equals -10 and poly.width equals -20. So I've now created a polygon with a length of -10 and a width of -20. Is that allowed, guys? Does that even make sense? Can we have polygons with negative width and negative length? No, right? You can't create a polygon with negative width and negative length. It doesn't even make sense. So maybe we wouldn't want the user to be allowed to do this. Okay. So how do we control this? Well, one obvious way is to just think about this keyword. Okay. So public means it's accessible everywhere. What if we make something private? How will that change the code? So I'm going to say private. Okay, private int length, private int width. What does that mean? Now you see when I run this, it says polygon.length is inaccessible due to its protection level. Polygon.width is inaccessible due to its protection level. But notice what's happening here. So it says there's an error on line 18. There's an error on line 19. So if I go to line 18, you can see I'm trying to set polygon.length, and it says you're not allowed to do that. Polygon.length is private. I then try to set poly.width on line 19. This is this error, and it says you're not allowed to do that. It's private. I then try to display polygon.length on line 21. And again, it says, no, that's not allowed. It's private. I then try to display polygon.width on line 22. And it says that's not allowed. It's private. Okay. So by setting it to private, I am no longer allowed to see or change polygon.length or polygon.width. Okay. So if I have this private keyword, then that's what it does. It just makes it so that I am only allowed to modify and see length and width inside the class. So for example, just to show you guys, I am going to stop trying to modify all of these. So I'll comment out all of these. Okay. And instead of trying to access poly.width here, I'm going to access poly.area. Okay, notice that area is set to public. So the area method, poly.area. When I run this, you see it works. It doesn't give me an error. It returns length times width, which happens to be 0, 0 times 0. So that's 0. So you can see it allows me to access the area method. And it allows me inside the area method to access length and width. Even though length and width are private, because this is happening inside the polygon class, it's allowed. Okay. So inside the polygon class, I'm allowed to access length and width. All right. You guys get that? I hope so. Cool. So moving on from there, we've now got a private length and a private width. Now, that means that I'm not allowed to set it to anything outside the class. I'm not allowed even to see it outside the class. That's a bit extreme, right? I think we can agree that's a bit extreme. So maybe I want to be able to provide a way to, even though length and width are private, I want to be able to edit them at least a little bit. Oh, by the way, I do want to just show this to you guys. If you don't specify, it will automatically set it to private. Okay, so if you don't tell C# that it's private or public, if you don't tell it that it's private or public, it'll automatically be set to private. And the reason for that is because C# wants to err on the side of safety, right? So it wants to be safe. So if you don't tell it that it's public or private, C# will assume that you want it to be private. Okay, cool. So moving on from here, what we can do is create something, and this is an important idea. I want you guys to remember the name of these. So 2 more words. I know, lots of words. I did warn you guys though. Chapter 2 is very definition heavy. But once you've learned all these words, you can do some pretty cool programming stuff with them. Okay. So how we do this is a thing called getters and setters. Getters and setters. The other sort of fancier word is accessors and mutators. Accessors and mutators. So what these allow you to do is to get and set private variables. Get and set private variables. So notice what we've got here. I'll show you on length. So I'm going to remove things just again to keep it simple. Currently, I'm trying to set length to -10. All right. This was the problem we were trying to remove. Remember, I'm trying to set length to -10. And you can see that because length is 10, it's just telling me, look, you're not allowed to access length at all. It's because of its protection level. Okay, you're not allowed to access length. What I can do is add a getter and a setter to allow me to set and get length, okay, even though it's private. So how I'll do this is I'm going to say, number one, I'm just going to rename this. Okay. Actually, no, so I'll leave it like that just to make it clear. Okay, so I'm going to create a method. Right? Notice, remember guys, that I could access area because it was public. So I'm going to create a public method, okay, called length. And it's going to return an integer. You guys see that? It returns an integer. There is a keyword in C# called get. Get. when the user uses this, when the user tries to access length, notice length has a small l, right? It's not allowed because polygon.length is inaccessible due to its protection level. But the length variable is the length method here with capital L is public. Okay? So here I can access return length, okay, with a small l, right? Likewise, there is another keyword called set. So now you know why these are called getters and setters, which will allow me to say length equals value. Value is just a special thing, so whatever's given on the right of the equals sign outside of this will allow me to use this. Okay, but I'll show you now how this sort of solves our problem. So now look, when I run this, okay, you see it still says polygon.length is inaccessible due to its protection level, like we were working with before. So I'm saying polygon.length with a small l, it's trying to access this private variable and it's not allowed. How have I fixed this? Well, if I now say polygon.length, capital L, because I've created these getters and setters and a public method called length, when I say poly.length and poly.length, it will now allow it. So you see it's now allowed. Even though length is private, the length, capital L, method is public. Okay. So pretty special idea here. And you can see maybe why they're called getters and setters. How does this solve our problem? Remember, we were saying that it's pretty weird that you can set the length to whatever you want. Well, now you have to, when you set length, you have to set it through this setter. And so when you set it, I could hypothetically check that the length is positive. Guys, how would I check if an integer is positive? What statement would I use? Anyone? What statement will I use to check if the value that you are trying to set length to is positive? See, you guys have been exposed to a lot of new words, but don't let it intimidate. So exactly. So Chris has said that we would use something like greater than 0, and that's true, or greater than or equal to 0, right, Chris? Because you can set the length to 0. Well, I guess, can you? It depends. Can you have a polygon with length 0? Not really, but yeah. So we could use greater than 0, greater than or equal to 0. But what statement will I put that inside to actually use it? So that's how we ask the question. We say greater than 0, but what statement will I put that inside? An if statement, precisely. Okay, so Chris, you're very much awake. You're doing good. So if we say if value is greater than 0, then set length to value. So now what will happen is when I try to set polygon.length to -10, it will refuse. So I'm going to run this. You see it's still 0. See, it's still 0, even though I set it to -10. But if I set it to +10, it's now okay. It'll set it to 10. Okay. So this is why we make things private, because we can control how you set it. We can control how you set it. And you can think there's lots of cases where you would want to do this, right? Like if you have a class that has a password in it, you would set the password to private. If the user wants to change their password, you know, they have to make it like greater than 8 characters. It has to have a special character. All of those things we can check with if statements. Okay? So there are many cases where you want something to be private so you can control how you get and set it. How do we control how we get and set things? We use getters and setters, right? Let's say, as another example, you want someone to only be able to get it. So you're allowed to see the length of the polygon, but you can't change it. Okay. Well, then I could just remove the set. Okay. So now it's only got a get. And so now it's not possible to set length. Poly.length equals -10. Can't happen, not allowed. I have to comment it out. It'll just give you an error. And when I run it again, I'm still allowed to see poly.length, but I can no longer set it. So this is what we call read only. So guys, you've heard a lot. Another analogy that can help you think about this public-private idea is you've heard a lot when working with computers, I'm sure, this idea of reading and writing, right? So for example, if you open up a Word document that someone sent you, sometimes you can read the Word document, but you're not allowed to modify it, right? That would be called read only. So what that means, read only, what it means is that it's only got a getter. You can get what is in the file, but you can't modify it, right? If you want to be able to modify and read, then you need a getter and a setter, all right? Cool. Hopefully that all makes sense. And yeah, the last thing about this getter and setter idea is that you can do it automatically. So let me just show you guys this quickly. So I'm going to go back a little bit. You can see, so this is the getter and setter for the length property, okay, the length property. You can imagine now I could go ahead and do the same thing for the width property. Okay, so I'll just type it out to show you. So I could say public int width, something like this. And then I could say gets, and this time we'll be saying return width. And we'll say set, something like that. And we say if value is, or let's ignore the greater than 0 thing. Okay, we're just going to say you can set it to whatever you want. Okay, so width equals value. And then here I'm just going to say length equals value. Just to keep things simple, we're going to ignore the conditions that we have. You can see that these are super similar, right? We've got public int width and public int length. Both of them are just capitalized versions of the actual variable name, the actual field name. And we've got a get that returns width. We've got a get that returns length. We've got a set that says length equals value. And we've got a set that says width equals value. These are extremely similar, and it took quite a while to type them out. Programmers are very lazy, and so this is not usually how we do it. Okay. C# can do what is called auto implementation. So I'll type it in the chat just so you guys can see how it's typed. Auto implemented getters and setters. Auto implemented. So the auto obviously just stands for automatic. So what you can see is I'm going to delete this length and width, these getters and setters, and I'm going to do the exact same thing, but automatically in one line. Okay, so I'm going to delete all of this, all of the getters and setters. There we go. They're all gone. We've now gone back to just having private int length and private int width. I can do the same thing by just saying public. I'm going to make them both public again. I'm going to capitalize them. So length, length. And then I'm going to open up curly brackets like so. And I'm going to say get, set, run this. I need to remove the semicolon, sorry, like that. And then this must become length with a capital, and this must become length with a capital, just a couple of changes, and now it all works. Okay, so what changed here is that it now just creates the getters and setters automatically because I put get and set inside these semicolons. Inside these curly brackets, sorry about that. Okay, so it just created those getters and setters automatically for me. Why is this still cool? Well, if I remove set, so I'm just going to write get, semicolon. So you see I've said length get, so there's no setter anymore. When I run this now, it gives me an error. It says property or indexer polygon.length cannot be assigned to. It is read only. It is read only. So because it only has a getter, I can see what length is, but this line here, line 18, where I say poly.length equals 10, because there's no setter, it's not allowed. So now I'm allowed to see length, but I can't set it. If I want to be able to get and set it, then I have to say set over here. Okay. And now it works again. All right. So that's just a faster way of defining that idea, right? Cool. So that's two words, all right? So public means that it is accessible anywhere. Private means that it is only accessible inside the class unless you create getters and setters. Okay? So private means that it is only accessible inside the class. If you want to access a private property, you have to add getters and setters, all right? So if you want to access a private field, rather, then you would have to add getters and setters, which makes it a property. Okay. So we've got public, that's accessible anywhere. Private is only accessible inside the class. If you want to access those private properties outside the class, you have to add what we call getters and setters, or accessors and mutators. Okay, it means the same thing. All right. There's also this idea of auto-implemented getters and setters. So C# can do it all for you automatically in one line. All right. So that's quite useful, quite convenient. The last word I have on this slide here is protected. Protected is very similar to private. So I'll show you what protected does. Okay. So you can see currently we've got these public getters and setters. Okay, length and width are actually private, but they have getters and setters. So we're allowed to modify them outside the class, and those getters and setters are public. How we can change this is I can, instead of writing public, I can just write protected, protected. Now what you'll notice is when I run this, so I'm going to run this, it's now not allowed. So it says polygon.length is inaccessible due to its protection level. So that's on line 18. And then on line 20, again, when I try to access poly.length, it says it's inaccessible due to its protection level. So what is protected doing? Protected is related to this idea of inheritance. So notice, public means it's accessible anywhere. Private means that it's only accessible inside the class. Remember that we had this idea of inheritance as well, right? Where we could say something like, rectangle inherits from polygon. So what protected means is that you are able to access it inside the class that it is from, and you are able to access it in any derived class, so in any class that inherits from that class, but you are not able to access it anywhere else. Okay, so you're able, if it's protected, you're able to access it inside the class that it is made in. You would be able to access it in any class that inherits or that is derived from the class that it is made in, but you are not able to access it anywhere else. Okay, so let's see this. Okay, so now because length and width are now protected, I am no longer able to access them directly like this with poly.length and poly.width because they're now protected. Okay. Watch. So I'm going to create a rectangle now. So I'll say rectangle rect equals new rectangle. I'm going to provide it with its length and width for the constructor because the constructor expects the length and then the width. So I'm going to give it 10 and 20 as we did previously. Notice the constructor here for rectangle is accessing length and width, which is the properties that it is inheriting from polygon. It is allowed. You see it's allowed. If I made these private, so let me make them private again, just to show you. Private means that it is only accessible inside the polygon class, right? If they're private, it means it's only accessible inside the polygon class. So I'm going to run this quickly. And you can see, so it runs, and then it says polygon.length is inaccessible due to its protection level on line 32. So this is line 32 inside the rectangle constructor. So even though rectangle inherits from polygon, it's not able to access length because length is private. If I made length public, then it would be okay, but then I would also be able to access length inside any other class, right? Even if it doesn't inherit. Protected is like the middle ground. Protected will allow me to access length in anything that inherits from polygon, so rectangle or square, but it would not allow me to access it in any other class. Okay. So protected is like the middle ground between private and public. Okay. Private is only accessible inside the class. Public is accessible anywhere. Protected is accessible in any class that inherits from the base class. Okay. And that is actually that for encapsulation. All right. There is another word. They never ask you about this word directly, but I am just going to tell you what it is. They'll never ask you about this word directly, and it would be weird to spend time on because it only applies in really large projects. There is another word called internal. Internal means that the access is restricted to the same assembly, which is basically like the same project. So you can imagine if you're working in a large company and they have a C# app made for mobile phones and a C# app made for websites or like desktops, then you would have, if something is internal, that would mean that it's only accessible for the mobile application or only accessible for the desktop application, okay? But obviously we're not making projects that large, so the internal keyword we won't demonstrate, okay? But just know that it exists. They'll never ask you about it directly. What they will ask you though is public, private, and protected. Public, accessible anywhere. Private, only accessible inside the class. Protected, accessible inside the class or in any class that inherits from it, okay? So those are the three keywords about encapsulation. And you can see that they're all about security. Okay, they're all about security and permissions, right? Like read only and stuff like that. Read and write, that sort of thing. Okay. Awesome. So that's that for encapsulation. That's the second big OOP concept. So we have made it through inheritance, where we learned a lot of new words. We made it through encapsulation, where we learned a lot more new words. And now we are going to move on to polymorphism and abstraction. Okay, polymorphism and abstraction. The first next one is polymorphism. Polymorphism is Greek, okay, it's Greek. Poly, as we discussed with polygon, right? So poly just means many in Greek. It just means many. Poly means many. Morphism or morph means forms, okay? So polymorphism is like many forms, many different forms. And that's a pretty good way of thinking about it. All polymorphism means is that a method can take on many different forms, okay, in all of the classes that it's used in. So I think we've actually got a pretty good way to demonstrate this over here, okay? So I'm going to go ahead and make the polygon class abstract again, just to tie in all the ideas that we've seen so far. Cool. I'm going to go ahead and create another square class. Okay. I'm just going to create it again. And I think it's okay too, because you know it's good practice anyway. So I'm going to come over here and I'm going to type sealed. So I'm making it sealed, which means you won't be able to inherit from it. Okay. Sealed public class square. And it's going to inherit from polygon. And I'm going to create a constructor for the square again. So public square int L for length. And it's going to set the length equal to L, but it will also set the width equal to L. And this is just the properties, the protected properties, length and width, that it is inheriting from the polygon class. Okay, so that's our structure there. It's not too bad. And you now, guys, you basically know every single word on this. Okay, you know the meaning of every single word that's used here. You know why it's there, which is quite cool. Made a lot of progress already in chapter 2. So that's nice. I'm then just going to quickly create another square object. So I'm going to say square sqr equals new square and just set the length and the width to 10. Okay. So we've got this idea here. Polymorphism applies to methods. Okay, so we've only got one method here, this area method. What polymorphism means is that C# allows this method to take on many different forms. Okay, so both rectangle and square can access area. We've seen this before. Console.write line, console.write, sorry. And you can see we can say rect.area and we can say square.area. Okay, something like that. And when I run this, you can see it'll print out the area of our rectangle and the area of our square. What I want to do now is to actually print out a special message. Okay, along with the area, I'm going to print out a special message that tells me if this is the area of a polygon, okay, the polygon class, if it's the area of a rectangle, or if it's the area of a square. All right, so I'm going to specify every single one. Okay, so let's do that, and we'll see how that goes. Okay. So instead of returning an integer, what I'm going to do is just make the area method print out this message. Okay. So it's no longer going to return the area. It's just going to print out in the message. So guys, what's the keyword I use when I want a method to return nothing? You guys remember? If I want a method to return nothing, what do I need to change that int to? We've got, so the int there says that this area method returns an int. Yo, Chris, Clark, nicely done. Yes, precisely, you guys both got it. That's cool. Void is the word. So void, that means it returns nothing. Okay. Void means it returns nothing. Okay, so this now no longer returns an integer, it returns nothing. And all I'm going to do here is make the area method print out. So this, we're inside the polygon class. So I'm going to say the area of this polygon, is, and I'm going to use a special little trick here. All this is doing is giving a template. So what this is saying is it's going to replace this curly bracket with the 0 with the first argument, sorry about that, with the first argument that comes after. So I'm going to say comma length times width. So what it's going to do is replace that 0 with whatever the length times the width is. Okay. So let me just show you. So you can see it says that I call rect.area, and it prints out the area of this polygon is 10 times 20, which is 200. And then when I call square.area on the next line, on line 20, it says the area of this polygon is 10 times 10, which is 100. Okay? So all it did was replace that 0 with whatever length times width was. So it's just a special way to print out. You won't be tested on that, but I didn't want you guys to be confused about what's going on that line. Okay, cool. So we've now got this thing that says the area of the polygon is this. But you agree, so on the second one I call rect.area. On this next one I call square.area. I don't want it to say the area of this polygon is I want it to say the area of this rectangle, if it's called from a rectangle object, and I want it to say the area of this square, if it's called from a square object. All right? So how I need to do this is this area method needs to take on a different form if it is inside a rectangle class or if it is inside the square class. So C# provides a way for it to have these different forms. And there are 3 words that we need here. Okay? The first word is virtual. Virtual. We'll probably only cover the last important OOP concept abstraction next week, because we've only got like 11 minutes left, but we should be able to finish polymorphism, so that's cool. There's a special keyword, virtual, and all that does is, you can see here it says underneath, virtual marks the method as alterable. So this marks method as alterable. You'll see what I mean by that now. So I'm just going to say public virtual void area. What that tells C# is, look, so I've defined this area method, but if a class that inherits this area method also defines a method called area, then just use that one instead. That's what that virtual is basically saying. This is just, this area method does exist. It can be used, but you don't always have to use it. Do check if inside a class that inherits from Polygon, if it defines its own version of area, then maybe use that instead. Okay, cool. So that's the first word we need for this idea of polymorphism for many forms. So this just marks that method, that area method, as a polymorphic method, basically. Okay. The next word we need, there's actually two words and they are related. They're slightly different. The words are new and override. New and override. Okay. The new keyword hides the functionality of a virtual method, and the override method overwrites the functionality of the virtual method. So there are two different ways I can do polymorphism. One of them is new and one of them is override. And we're going to see the difference now. Okay, so I'll show you guys, don't worry. We'll see it all in this example here. So I have marked the area method as virtual. So what that means is inside this rectangle and the square classes that inherit from Polygon, Polygon defines the virtual method area. So inside rectangle and square that inherit from Polygon, we can use polymorphism to change the way that the area method works. So what I'm going to do is say public. I'm going to use one of our special new keywords here, either new or override, and we'll explain the difference now. But otherwise, it's going to be exactly the same. So it's going to be public, whatever keyword I'm going to choose to use, void area, and I'm literally just going to copy the console.writeLine. Literally just copy it. Control C. But instead of printing out polygon, I'm going to print out rectangle. So the area of this rectangle, because I'm inside the rectangle class, is length times width. So otherwise, it's the same. This one just says rectangle instead of polygon. Okay. Now, which keyword do I use? You'll see that pretty simply, initially, they'll look like they do the same thing. So first, I'm going to try new. Okay, so I'm going to say public new void area. Public new void area. And I'm going to call rec.area. Okay, notice I haven't overridden in square yet. I haven't used polymorphism in square yet. I haven't defined the area method. So square is still going to be using the polygon area method. Rectangle is using its own area method, this new one. Okay, the one marked as new over here. So when I run this, you can see it says, when I call rect.area, it says the area of this rectangle is 200. So that's using our new method. When I call square.area, it says the area of this polygon is 100, because we haven't defined square its own method yet. So what I'm going to do now is also define the new method inside square. Okay, but this time I'll use the other keyword, and it'll be very similar. So in square, I'm going to come here and I'm going to say public, whatever keyword I'll use, void area. Okay, and all we're going to do here is cool. So I've defined this this new thing, and I'm just going to use the word override here instead. Okay, override. Okay, cool. So otherwise they're the same, and this one is obviously just going to say the area of this square is whatever. Okay, so the one's just using new to be polymorphic. The other is using override to do the polymorphism. Okay. Initially, I'm going to run both. You can see that it's basically the same. New and override seem to be doing the same thing, right? So the first one says the area of this rectangle is 200. The next one says the area of this square is 100. So the polymorphic methods are both just replacing the initial implementation, which was the area of this polygon is whatever. Okay. So what's the difference between new and override? Well, you can kind of see on the slide. So it says new hides the functionality of the virtual method. Override overwrites the functionality of the virtual method. Okay. Now, there is only one way to actually see the difference. Okay. And it'll look pretty weird, but I am going to show you guys anyway. It is related to this idea of inheritance. In order to show it to you, we're going to actually have to learn another new word. It's the last one of this week's lecture, I promise. We're going to have to learn the word is. Is. So you see, when I type is, it's highlighted in purple. What is does is if the thing on the left is the same type as the thing on the right, then it will print out true. Okay. So I'm just going to show you guys quickly. Console.write line. I'm going to comment out the area prints quick, just so that we don't have to think about too much. And here on this line, I'll do it quickly. So I'll say int x equals 6. Right? I'm going to say x is int. X is int. When I run this, you see it prints out true. Why did it print out true? The thing on the left is the same type as the thing on the right. Okay. If I say x is string, this will print out false. Okay. Now remember, when we create classes and objects, we're just using and creating our own types. We're just creating and using our own types, right? The same as ints and strings and all of that stuff. So that's true here as well. If I say rect is rectangle, so rect is the name of my rectangle object, rect is rectangle. Can you guys tell me, what will this print out? What will this print out? Rect is rectangle. What will that print out, guys? You can see I create true. Precisely, Yusuf. It'll print out true. So when I run this, you see it prints true. If I say rect is square, what will that print out? False, precisely. So when I run this, you see it prints out false. What if I say rect is polygon? Ooh, weird case now, right? Okay, Yusuf says true, and that's a good bet. Yes. So when I run this, it says true. Because rectangle inherits from polygon, it is a polygon. Okay. I had to show this to you guys because what this allows us to do is, you see here I say rectangle rect equals new rectangle, right? Because rectangle is a rectangle, right? So new rectangle is a rectangle. So I'm allowed to save a new rectangle into a rectangle variable. So here I create a variable of type rectangle called rect, and I save a rectangle into it. Because rectangles are polygons, I can actually say polygon rect equals new rectangle. Okay, that's fine. C# doesn't mind this because rectangles are polygons. All right, because it inherits, it's allowed. And this is the difference between new and override. This is where it comes in. Okay. So inside so I'm going to do the same for both because squares are also polygons. So I'm going to say polygon square equals new square and polygon rect equals new rectangle. And I'm going to call the area methods on each. The only difference here is that inside rectangle, we use the new keyword to define our new area method. And inside square, we used the override keyword to define area. Okay, so when I run this, you can see that the rect.area uses the area of this polygon is 200. The area of this polygon is 200. Okay, so it is using the polygon classes version of area. The square.area prints out the area of the square is 100. So even though this square is saved in a variable of type polygon, it used the squares version of area. Okay. So basically, this was all a long way of explaining, or well, the shortest way you could, I think, the difference between new and override. New hides the original implementation of area. If you're saved in a polygon variable, polygon rect equals new rectangle, this version of area, the area of this polygon, still exists, and you'll use that because new just hides it away. Okay? If you're inside a rectangle object, then you'll use this version of the area method. If you're inside a polygon variable, you'll use this size, this version of the area method. Okay? The override keyword doesn't hide it away. It overwrites it. Whether you're a polygon or a square, when you use area, you will be using this version of the area method because the other one has been overwritten. It wasn't hidden. New hides it away. Override overwrites it. Okay, that's the difference between new and override. And that's the end of polymorphism. It's just those three keywords: virtual, new, and override. That's polymorphism for you. Okay. The last thing we will need to learn about is abstraction, but we'll do that next week because we have used the full 2 hours now. And I know there was a lot today. I will give you guys, I think I'll probably have it set up by tomorrow. I'll give you guys a little practice assignment / exercise where you can practice inheritance and polymorphism and stuff, in particular polymorphism. And then I'll give you guys that little assignment if you want some practice, some practical practice. But remember that the important things are these theory questions because that's how you're tested. Okay. So yeah, I'll give you that because we can't really practice object-oriented programming through Code Wars, unfortunately, because it's very, Code Wars is more like puzzles than OOP, okay, than projects. Cool, but yeah, we're done for today, guys. Thank you guys for coming. Enjoy the rest of your weekends. And yeah, see you next weekend. See you next Saturday. Yeah, thank you for coming, Chris. You too.